we're going to start talking about standard maximization problems. And unlike the problems that we did where we usually had an x and a y, now we're going to have problems with 3 variables, 4 variables, 5 variables, and so on. Instead of naming our variables x and y, we're going to need more variables, so we're going to use names like x sub 1, x sub 2, x sub 3, however many we need. The inequalities that we'll have that give us our constraints are going to have a form a sub 1, x sub 1, plus a sub 2, x sub 2, plus a sub 3, x sub 3, all the way up to however many variables we need, less than or equal to b. A sub 1, a sub 2, a sub 3, and b are all going to be constants. So let's take a look what it means for a linear programming problem to be in standard maximum form. A linear programming problem is in standard maximum form if the following conditions are satisfied. First of all, the objective function is to be maximized. Second, all the variables are non-negative, so the x sub i's are greater than or equal to 0. And third, all the remaining constraints have the form a sub 1 times x sub 1 plus a sub 2 times x sub 2 plus a sub 3 times x sub 3 up to a sub n times x sub n is less than or equal to b, where b is greater than or equal to 0. So let's go ahead and look at one of those types of problems. So here I have a standard maximization problem. So there's our objective function, and it's written out as z equals 8 times x sub 1 plus 3 times x sub 2 plus x sub 3. We have our non-negativity constraints. X sub 1 is greater than or equal to 0, x sub 2 is greater than or equal to 0, and x sub 3 is greater than or equal to 0. And we have our constraints. So all the stuff on the left-hand side is a number times a variable. And on the other side, what we have are non-negative numbers, 118, 220, and these are all less than or equal to.